Welcome back, it's Rigers Bakiu. I'm happy to be back with you for the third tutorial in the MedPAN regular training program series entitled Getting Started on How to Characterize Fishing Activities in Your Marine Protected Areas. Today, we'll focus on the main target species of Mediterranean fisheries, looking at their biology, life cycle, and key characteristics relevant to MPA management. In this first section of the tutorial, we will cover some key concepts on the biology and life cycle of marine species that are essential for effective management of marine protected areas. Certain life history characteristics like age at maturity, growth rates, fecundity, and lifespan can help identify the vulnerability of a fish species to overfishing. Reproductive biology, which is about understanding the reproductive behavior, timing, and location of spawning, is essential for protecting fish during their critical life stages. Migration patterns, that is, knowing where fish migrate and where they come from, is important for managing their populations and can help make decisions about the size and location of the MPA. Knowledge of the habitat requirements and diet-trophic relationships of marine species is also essential for effective MPA management. Indeed, marine species rely on a range of habitats. Protecting a variety of habitats and ecosystems is important for ensuring the survival of many species that depend on them. In terms of diet, marine species will consume a variety of prey items depending on their feeding habits and the availability of food. For example, carnivorous fish such as groupers and snappers may prey on smaller fish and invertebrates, while herbivorous fish like parrotfish feed on algae and seagrasses. Marine mammals such as dolphins and seals may feed on fish, squids, and crustaceans. Additionally, some species may have important ecological roles as both predators and prey, such as the octopus, which feeds on small crustaceans and fish, but is also preyed upon by larger fish and marine mammals. Overall, marine protected areas are important for maintaining the health and diversity of marine ecosystems and can provide important insights into the diet and trophic relationships of marine species. By protecting key habitats and species, marine protected areas can help to maintain healthy and resilient marine ecosystems and support sustainable fisheries. Understanding the biology and life cycles of marine species enables MPA managers to identify critical habitats, movement patterns, and spawning grounds of fish populations and design effective management strategies to protect these populations and their habitats. This will, for example, allow the identification of fishing seasons, gear types, and fishing techniques that minimize the impact of fishing on vulnerable fish species. To begin with, let's take a look at how fish reproduce. All fish do not reproduce in the same way. For example, some Mediterranean fish like groupers or sea breams build nests on rocks or in crevices to lay their eggs, which makes them particularly vulnerable to disturbances on the seabed. Many pelagic species such as bluefin tuna, swordfish, and anchovies release their eggs and sperm into the water column, which highlights the importance of preserving water quality and minimizing pollution in the open sea. Timing and location of reproduction also differ depending on the fish species. For example, bluefin spawn in shallow inshore areas during the summer, while sea breams spawn in deeper offshore areas during the winter. These diverse reproductive strategies have important implications for conservation and management of fish populations in marine protected areas. Knowing when and where the spawning occurs can help predict the recruitment of new generations of fish and sustain the population in the MPA. Knowing which species rely on specific reproductive habitats or behaviors can help us identify critical areas that needs protection and ensure the appropriate measures are taken to preserve their breeding cycles. Another important factor to consider when managing fisheries in marine protected areas is the reproductive maturity of the target species. This refers to the age at which individuals are capable of reproducing, which can vary greatly between different species. For example, species like gilt-edged sea bream and European sea bass do not reach maturity until they are 2 to 3 years old, while other species like octopus and cuttlefish can reproduce when they are only a few months old. To better understand the differences in age of maturity, let's take a look at some other marine species. The Mediterranean monk seal, a critically endangered species, reaches maturity at around 4 to 5 years old, similar to some fish. In contrast, the loggerhead sea turtle, a species listed as vulnerable, takes up to 20 years before reaching sexual maturity, whilst invertebrates like the sea urchin and the sponge can reproduce when they are only 1 year old or less. So, why is understanding reproductive maturity important for fisheries management? Fish that are caught before reaching maturity may not have had the chance to reproduce and contribute to future generations. This can result in declining populations. By setting fishing limits based on the age of maturity, we can ensure sustainable catches and preserve healthy fish populations. Fish fecundity, that is closely linked to reproductive maturity, is also essential in MPA management. The fecundity of many fish species can be influenced by factors such as age, size, and environmental conditions. Let's take the example of the European sea bass. Larger individuals have a higher reproductive output than smaller ones. This means that the reproductive potential of the sea bass population can significantly change based on the size distribution of individuals. Therefore, managing European sea bass populations solely based on total biomass or fishing mortality might not be sufficient to ensure sustainability. It is also essential to consider the size structure of the population and the fecundity differences among individuals. This might mean implementing measures to protect larger individuals, such as implementing minimum size limits or closed seasons during the spawning periods. Overall, understanding fecundity and how it affects the dynamics of fish population is therefore crucial in developing effective management strategies to maintain the sustainability of fisheries. Fish spawning areas are incredibly important for the health of many species in the ocean. Spawning areas are typical locations where fish breed, lay eggs, and raise their offspring. These areas provide essential habitat for fish reproduction and development and are often critical for the success of fish populations. In the Mediterranean, several target species, as groupers and red mullet, rely on spawning areas. These areas not only support the reproduction of these species, but also attract smaller fish that serve as prey for larger predators such as sharks and dolphins. However, these areas are also vulnerable to overfishing as they are generally known to be home to the best breeding fish. Fish typically come to spawn from a wide radius, so the losses affect a large area. By protecting and managing spawning areas, MPAs help prevent overfishing, increase fish populations, maintain ecosystem health and biodiversity, and support the sustainability of fisheries as populations become more abundant with thriving populations in neighboring areas. Let's now look at spawning aggregations. What are spawning aggregations and what makes them vulnerable? During breeding seasons, many fish species converge in large groups at specific locations to release eggs and sperm for fertilization. This mass breeding strategy provides the best chances for fertilization and the survival of offspring. Spawning aggregations are an important component of the life cycle of many fish species. Species like grouper, snapper, and sea bream rely on these aggregations. However, overfishing and habitat degradation can threaten these aggregations, leading to a reduction in the per capita reproduction rate of fish and making them vulnerable to population declines. Additionally, selective fishing pressure can drive genetic evolution towards smaller body sizes and slower growth rates. If fishers only catch bigger fish, then smaller fish have a better chance of surviving and passing on their genes. Over time, this can result in a population that is genetically predisposed to be smaller in size and grow more slowly, which can make it harder for them to reproduce successfully. Overall, spawning aggregations are an essential part of the breeding behaviors of many fish species, and understanding and protecting these sites are crucial for maintaining healthy populations of these species. Recruitment is another important concept to understand when it comes to managing fisheries sustainability, particularly in the Mediterranean, where many fish species are heavily targeted by both commercial and recreational fisheries. Recruitment refers to fish reaching the legally required catch size, ensuring they have had enough time to reproduce and contribute to the sustainability of fish population. Recruitment can be influenced by many factors such as water temperature, food availability, and predation rates, as well as fishing pressure, which can remove a large number of fish before they have the chance to reproduce. Understanding recruitment dynamics of target species and their vulnerability to fishing pressure is therefore important in order to establish effective management strategies and fishing guidelines and regulations. This is particularly important in relation to maintaining critical spawning and nursery habitats in MPAs. Marine species have different home ranges or habitats where they can thrive and carry out their life functions, like eating, living, and reproducing. And of course, not all marine species have identical ranges or habitats. Some species, such as monk seals and dolphins, have a large range that can migrate long distances to feed and reproduce. Other species, like seagrasses, have a more fixed range and are limited to certain areas based on environmental conditions. Additionally, different life stages of a species may require different habitats. For example, some fish species may spend their juvenile stage in seagrass beds, like Sparida family members, while their adult stage may require open water habitats. The diverse range of habitats in the sea is crucial for supporting the rich biodiversity of marine species. A marine protected area may therefore include the entire habitat and home range of certain species within its perimeter, while only partially protecting those of other species. For example, on the slide, the dusky grouper will be able to benefit from a few square kilometers of fully protected area, whereas the fully protected area will only cover a small portion of the home range of the monk seal, which moves over much larger areas, which are up to 100 square kilometers or more. Understanding the home range or habitat of marine species is therefore essential for their conservation. And there are several reasons for this. Habitat protection. By identifying the range or habitat of a species, conservation managers can focus their efforts on protecting and managing those specific areas. This includes implementing measures to reduce human impacts such as fishing, pollution, and coastal development that can harm or destroy the species' habitat. Population monitoring. By tracking the movements and distribution of species within their range, managers can monitor population sizes and trends. This information can help to identify areas of concern and inform conservation strategies such as implementing fishing quotas or establishing new marine protected areas. Recovery planning. For species that are endangered or threatened, understanding their home range is critical for developing recovery plans. By identifying and protecting critical habitat areas, managers can increase the likelihood of species recovery and survival. Ecosystem management. Many marine species play important roles in maintaining healthy marine ecosystems. By understanding their range and habitat requirements, managers can work to protect and restore entire ecosystems, which in turn benefits a range of species and supports sustainable fisheries. In summary, understanding the home range of marine species allows for targeted efforts to protect critical habitats, monitor populations, and develop recovery plans for threatened species, all of which contribute to maintaining healthy and sustainable marine ecosystems. This understanding is essential to MPA design and management. Let's now take a look at the effects of fishing on population dynamics, and more specifically the consequences of large-scale removal of older fish. When we fish, we generally target the larger, older fish in the population. This means that over time, the average age and size of the fish in the population becomes younger and smaller. If we continue to remove these older fish on a large scale, the age-sex structure of the population is likely to be disturbed. For example, if we remove too many older females from a population, then there may be not enough females to reproduce and maintain the population size. This can lead to a reduced population-sex ratio, which can be a problem for the long-term health of the population. In the Mediterranean, many species are particularly vulnerable to these effects. For example, the common dentex, which is differently known by its scientific name as Dentex dentex, is a popular target for commercial and recreational fishing. This species can live up to 20 years and reach sizes over 1 meter in length. However, due to overfishing, the average size of common dentex has decreased and the population-sex ratio has become more male-biased in some areas. A combination of measures and regulations such as catch limits, size limits, fishing gear restrictions, and special management can be considered to address the issue of large-scale removal of older fish. But do you know what the main target species are in the Mediterranean? Let's see who they are across the different fishing sectors. Looking at commercial fisheries, which includes large-scale or industrial fisheries, and the artisanal or small-scale fisheries, three species groups emerge as dominant, making up to 72.3% of total reported landings. The first group includes herring, sardines, and anchovies. The second one, miscellaneous coastal fishes, and the third one, miscellaneous pelagic fishes. 7 other species groups contribute to 22.5% of the total landings, while the combination of all remaining species amount to 5% of the total landings. Industrial fisheries in the Mediterranean primarily target species like the European pilchard, anchovy, European hake, red mullet, monkfish, lobster, shrimps, clams, mussels, and crabs. As can be seen from the graphs of landed catches on this slide, overfishing and unsustainable fishing practices have led to a significant decline in several of these species targeted by industrial fisheries in the Mediterranean Sea. This is, for example, the case for the sardine and European hake. As you can see, landed catches and consequently relative biomass have also varied over time for the European anchovy and deep-water rod shrimp, although catches have remained almost stable for these two species compared with the other two. An important characteristic of small-scale fisheries is that the volume of catches is much less than those of industrial fishers, but with a wider range of target species. This versatility potentially makes small-scale fishing more sustainable, as it has a reduced impact on biological communities compared to capturing the same volume from a lower number of species. The list of species targeted by small-scale artisanal fisheries is therefore quite long. According to this chart showing the value of fishing catches, species significantly targeted by small-scale fisheries throughout the Mediterranean basin include the common octopus and the cuttlefish, spot-tailed mantis shrimp and canamonte prawn, the common sole and spirida family members, in particular the gilded sea bream and common Pandora, which are appreciated everywhere for their delicate white flesh and have a high commercial value. But then again, the list can be extended with sub-regional variations to many other target species, from European sea bass and dentex to mallet, Atlantic bonito, swordfish, and many more. In the Mediterranean, recreational fishers frequently target species that are also sought by commercial fishers, both in large-scale and artisanal sectors. Some of the key species include bluefin tuna, a precise catch in many regions, small pelagics, especially from the Scomberidae family such as Atlantic mackerel and Atlantic bonito, large pelagics, notably Carangida like greater amberjack, and lairfish, but also Xiphidae like swordfish, Coryphenidae such as dolphinfish, Coryphena hipporus, Sparidae including gilded sea bream and common dentex, cephalopoda like European squid, common cuttlefish and common octopus, and other commonly targeted species like the European sea bass, European conger, mullet, or different species of groupers. Although these species are widely targeted across the Mediterranean, preferences may change from one subregion to another. The overlap in target species between recreational and commercial fishers can lead to potential conflicts, underlining the importance of developing coherent and harmonized management frameworks. This alignment is crucial for species commonly targeted by both sectors in order to ensure sustainable fishing practices and the conservation of marine ecosystems. Continuing with this tutorial, we will take a closer look at a limited number of target species that may be of particular concern for fisheries management in the Mediterranean marine protected areas. To narrow down the broad list of target species, we will consider 1. Species that are most common in different parts of the Mediterranean. 2. That are targeted by both commercial and recreational fishing. 3. Whose life cycle is partly coastal, as most MPAs are coastal. 4. Which are subject to moratoria or regulations widely across the Mediterranean. And 5. That can be used as an indicator in the MPA management. This tutorial is obviously not intended to cover every possible target species, so this criteria will help us draw up a limited list of species that we will shortly be looking at more closely together. But as MPA managers, you should monitor your own list of target species based on your own criteria, according to your conservation priorities and the characteristics of your local fisheries. For example, in the Côte Bleue Marine Park in the south of France, 24 target species are monitored. The list includes their scientific and common names, minimum authorized size, maximum size, diets, UCN status, and a vulnerability index. Following this example, it is important to focus the monitoring effort on a limited list of relevant target species using cost-effective protocols that meet your management needs and can be maintained over time. But let's get back to the list of target species we will consider in the final section of this tutorial. We decided to focus on species most commonly found in the Mediterranean, targeted by commercial and recreational fisheries with a partly coastal life cycle relevant to MPAs, subject to widespread regulation and useful as indicators in MPA management. Besides these 5 criteria, we will choose species that are well documented in terms of growth, spawn period, diet, fecundity, and other important biological characteristics. It is likely that quite a few of these 15 species can be found in your marine protected area and are targeted by local fisheries. In this final part of the tutorial, we will look together at the identification keys and main characteristics of the 15 target species on our list to help you identify them. The European sea bass Scientifically known as Dicentrarchus labrax, is not only an important organ species for commercial and recreational fisheries, but also the marine aquaculture in the Mediterranean, similarly to the gilt-head sea bream. This silvery gray fish likes coastal waters with sandy, muddy, or rocky bottoms and lives in a range of habitats from marine to brackish and even freshwater areas. The sea bass prefers shallower waters but can be found up to 100 meters depth. It is known for its demersal lifestyle, living close to the seabed, and for its seasonal migration. It inhabits river mouths and coastal areas in summer and migrates offshore when the weather is colder in winter. They particularly like offshore islands. Young sea bass school together and feed on most types of sea creatures, in particular invertebrates, while adults are more solitary or live in small groups and hunt exclusively for smaller fish. The European sea bass reaches maturity at an average length of about 36 centimeters, with a general range between 23 to 46 centimeters. The maximum length encountered so far is 1 meter, while the maximum published weight is about 12 kilograms, and the maximum relative age reported is 30 years. The European sea bass can be recognized by smooth overlapping cycloid scales covering the area between the eyes of the fish, known as the interorbital space. It has a moderately protected mouth slightly extending forward with a crescent band of vomerine teeth that is a special band of teeth shaped like a crescent at the front of its mouth. The back edge of sea bass gill cover or opercle has tiny saw-like or zigzag notches, while the bottom edge has sharp, forward-facing points called denticles. There are also two flat spines on the gill cover. Young sea bass usually have dark spots on their upper body which might disappear as they get older. The common dentex, scientifically known as Dentex dentex, is a large and powerful fish found throughout the Mediterranean Sea. This fish stands out with its muscular, laterally compressed body growing up to 1 meter. It has a large hand and steep forehead, which is slightly darker than the rest of the metallic silvery gray body. It has obvious silvery lateral lines to the body and a long dorsal fin. Dentex species are usually solitary and are voracious hunters of small fish around shallow reefs, rocky walls, and wrecks. Beyond its ecological role, the common dentex is widely consumed and highly valued throughout the Mediterranean. The gilded sea bream, scientifically known as Sphaerus aurata, is a key species for commercial and recreational fishing, and also an important component of marine aquaculture in the Mediterranean. This fish is easily recognized by its tall body and distinctive large black spot on its gill cover. The snout, the part of the fish's head that extends in front of the eyes, is more than twice as long as the diameter of the eyes. The gilded sea bream reaches maturity typically within the size range of 33 to 40 centimeters at an average length of around 36 centimeters. The heaviest recorded weight was 17 kilograms and the oldest was aged 11 years. Gilded sea breams are commonly found in seagrass beds and sandy bottoms, as well as in the surf zone, commonly to depth of about 30 meters, though adults may occur to 150 meters depth. Known for their sedentary nature, these fish are often found alone or in small groups. In spring, they may be found in brackish waters or of coastal lagoons and estuaries. The gilded sea bream's diet is primarily carnivorous, feeding on shellfish like mussels and oysters, but they occasionally consume plants. The bogue, known scientifically as boobs, is a long silver fish with a metallic blue back and a distinct lateral line. It can grow up to 35 centimeters in length and can give life up to 13 years. Cylindrical in shape, it has a streamlined body and a thin, tapering tail. It can be recognized by the yellowish longitudinal lines on its flanks, although these lines may not always be clear. The bog forms large feeding schools and shallow reefs, and near the surface, often mixing with other fish such as smelt and chromis due to their similar diet, which consists mainly of crustaceans. During the day, they are found in shallow waters, but at night they move to deeper areas. This species is widespread throughout the Mediterranean, where they are a common target for both commercial and recreational fishers. An interesting feature of the bog is its hermaphroditism, starting life as a female and transforming to male as they age. This adaptation plays a crucial role in their reproduction and population dynamics. The annular sea bream, known scientifically as Diplodocus annularis, can grow up to 24 centimeters. This silvery species is recognized by its silvery body featuring a dark band around its tail and a wide vertical dull shade just behind the eye, extending from the top of the head to the gill covers. This fish enjoys coastal reefs and is commonly seen in small groups near sandy bottoms or rocky areas. The young often inhabit brackish waters. The annular sea bream is often confused with white bream due to their similar appearance. The striped bream, scientifically called Litognathus mormuris, grows up to around 55 centimeters and is widely distributed throughout the Mediterranean. The striped bream can be recognized by its silver color with 13 to 15 distinct vertical light gold stripes and an obvious high curved lateral line. As a bottom feeder, the striped bream digs into a soft sand looking for worms and small invertebrates and can be found in the sea as well as in brackish waters. An interesting fact about the species is its reproductive behavior. All individuals start life as males and later change to females upon reaching maturity, a form of hermaphroditism known as protandry, which is also observed in species like the gilded sea bream. The striped mullet, scientifically known as Mulus romulatus or commonly called godfish, is highly prized as a food species and therefore a popular target in both commercial and recreational fishing in the Mediterranean. Striped mullet grows up to 40 centimeters and can range in color from golden or orange with red patches to pale cream and browns. It's easily identifiable by its striped dorsal fin, long sloping head, and distinct fleshy lips. It has trim fleshy barbels, which it uses to sweep the soft sand or mud, searching for small worms and mollusks to eat. Striped mullet is usually working in pairs or small groups and is quite approachable. Commonly found in central and western Mediterranean regions, the common Pandora, differently known by its scientific name Pagellus erythrinus, is light tan to light brown in color and may have some pink and bluish spots at maturity. It can grow over 35 centimeters and has an elongated body with a tapering tail and a rather small head. The common Pandora lives on lower reefs and feeds on small crustaceans and mollusks. Like other sparrows, it has large crushing molars, which it uses to crush and grind its food. Interestingly, the common Pandora starts life as a female and transforms itself into a male at around 16 centimeters in size, a process of hermaphroditism similar to the bog, but different from that of the gilded sea bream and striped bream, which change from male to female. The great rockfish, also known as Scorpena scrofa, is the largest of the Mediterranean scorpion fish and can grow over 50 centimeters. It is highly prized in fish markets and restaurants and thus targeted by both commercial and recreational fishers. Recognizable by its tan and light brown color, it has many fleshy appendices underneath the jaw and around the head that provide excellent camouflage, helping it to blend into the rocky environments of the seabed. The great rockfish can be found in most habitats but prefers well-lit areas generally around seagrass meadows and among algae-covered rocks. Like other members of the Scorpionidae family, the great rockfish has venomous fin spines which, while less toxic then some relatives can still cause significant pain and infection, so be careful when handling them. The European hake, known scientifically as Merluccius merluccius, is among the species most targeted by Mediterranean fisheries. It is found from Norway and Iceland southward to Mauritania and also in the Mediterranean Sea and along the southern coast of the Black Sea. Its stock is considered overfished and management measures have been recommended by the GFCM to all Mediterranean countries. The European hake is recognizable by its slender body and a distinctive black color inside its mouth and gill cavities, while the second dorsal fin and the anal fin are serrated. It has around 50 vertebrae, the first vertebra and neural spine being attached to the skull. They reach maturity at an average length of around 42 centimeters, ranging from 20 to 70 centimeters. They can weigh up to 15 kg and live up to 20 years. European hake inhabit marine demersal zones typically found at depths ranging from 30 to about 1,100 meters, though they are most common between 70 and 400 meters. European hakes exhibit interesting behavior patterns where adults stay close to the seabed during the day and move off bottom at night. Their diet mainly consists of fish like small hakes, anchovies, pilchard, herrings, codfishes, sardines, as well as squids, while the young feed on crustaceans. European hakes are best spawners, which means that they don't release all their eggs at once. Instead, they spawn in groups or batches over a period of time. This strategy can increase the chances of their eggs surviving to hatch, as they are spread out over different times and conditions, rather than facing the same risk all at once. The brown migger, known scientifically as Siena umbra, is a robust fish with a silvery body which typically grows to around 35 centimeters. The head is dark in color and both the pelvis and anal fins have a strong white front margin set against a black background, which makes the rest of the fin appear almost invisible. Brown migger usually live in pairs and during the mating season from March to August, the males are known to produce a distinctive drumming or croaking noise. This sound is made using their swim bladder, an internal gas-filled organ that helps control buoyancy. The sound is not only a mating call but also a means of communication between the fish. The green wrasse, scientifically known as Labrus viridus, may not be the most popular fish on the market and is therefore not a prime fishing target, but it does occasionally end up in fishing nets and sold when caught. Typically small, around 15 centimeters in length, this fish displays shades of olive to golden green. There is some controversy over this fish, as it may actually be a juvenile form of another wrasse species, perhaps the brown wrasse, Labrus merula. As yet, however, the link has not been found. Ecologically, the green wrasse is known to favor seagrass meadows and small stony areas. It is quite timid and will quickly hide under stones if threatened. The red porgy, Pagurus pagrus, also known as the common sea bream, is a species of marine ray fin fish in the family Sparidae. It is found in the shallow waters on both sides of the Atlantic Ocean, including the western coast of Europe and the Mediterranean Sea. The red porgy is a seabed feeder with a diet consisting primarily of crustaceans, mollusks, and small fish. One of the most fascinating aspects of this species is its reproductive behavior. Like the book, the red porgy is a protogynous hermaphrodite, meaning that most individuals start life as females and then change sex to become males. Fish reach sexual maturity at the age of 2 or 3, but the sexual transition can occur at a wider range of sizes and ages, from 20.6 cm to 41.7 cm in total length, and from 2 to 9 years of age. Not all the red porgies undergo this change. Some remain primarily males with atrophied ovarian tissue before they reach maturity. Others are secondary males transitioning after a few reproductive cycles, and some stay females throughout their lives. The timing of the sex change in red porgy is believed to be influenced by social or environmental factors and an area of interest for marine biologists and conservationists. The dusky grouper, known scientifically as Ephinephelus marginatus, is an iconic species in the Mediterranean and a species of significant concern and interest. Often targeted by recreational fishers, particularly spur fishers, it is considered as endangered globally by the UCN. The dusky grouper is known for its rich brown color, mottled with pale cream spots and blotches, and can grow up to an impressive size of 1.5 meters. Dusky groupers are quite territorial, but they can gather in large groups in areas where food is plentiful, like in some marine protected areas. Their friendly and inquisitive nature makes them very popular among divers, but also makes them easy targets for spear fishers. These groupers can live for up to 50 years, making them one of the longer-lived fish in the Mediterranean. The Mediterranean rainbow wrasse, known scientifically as Coris ulis, is a colorful and slender fish that is often sought after by recreational fishers in the Mediterranean. It can grow up to 25 centimeters long and is characterized by bright color changes throughout its life. Typically, it displays a mix of horizontal stripes in a variety of colors ranging from yellow to vivid orange. Some may even have zigzag bands along the flanks. The Mediterranean rainbow wrasse is also recognizable by its pointed snout and tapered tail. Males and females can be differentiated by differences in colors and patterns, making them an intriguing species for divers and snorkels to observe. These wrasses are commonly found swimming close over the reef, feeding on small crustaceans and worms. They are known for their curious nature, often following divers around, possibly in hopes of catching any small prey that might be disturbed by the diver's movements. I hope that the two previous tutorials, as well as this introduction to the main target species, their biology, life cycle and how to identify them, provided you with some useful background knowledge for characterizing fishing activities in your marine protected areas. There are many resources out there to help you go farther anyway. You'll find many of them on the MedPAN website, especially this methodological guide for fisheries monitoring the Mediterranean marine protected areas, which will help you to select effective monitoring methodologies. Also, stay tuned to other MedPAN training courses, such as this advanced training